These are balancing equations found in your lecture notes. You must know how to count atoms before viewing this video, otherwise this may not make sense. These are the same equations that appeared in your lecture notes, except this is actual hearing me solve them. There is no silver bullet to balancing equations. I can only give you tips. So it's through practice that you begin to understand how to balance equations, and what works for you will not work for other people. So you need to figure out what works for you. First thing though is our goal is to make sure we have the same number of atoms on each side of the equation. You need to see what is not balanced at this time. I have 2 fluorines over here and I have 1 fluorine here. That's what is not balanced. So I'm going to put my number in front of the compound. Remember, you only put coefficients in front of the compound. I do not make subscripts. Remember, it's lithium fluoride as a balanced compound, so if I was to put a 2 here, it would no longer be a balanced compound. So you only put numbers in front of your compounds in the equation. So I have on this side 2 fluorines that balance on this side. However, whatever you put in front of a compound, it affects everything that's in that compound. So now I have 2 lithiums over here. I have to go back over here and put a 2 in front of that lithium so that it will balance it out. I go back and recount all my atoms to make sure that I have the same amount on each side, and I do. Next equation is this. There is no magic spot to begin. The only thing I can say is if it's taking you longer than 4 minutes and it's getting more complicated, you probably started in a bad spot. So right away, again, you start with what is not balanced. I have 2 oxygens over here and I have 1 here. I have 1 potassium here and 2 on this side. So for no reason, I'm going to start balancing my potassiums so that now I have 2 on this side and I have 2 on that side. However, again, remember our oxygens were out of balance. I have 2 here and 1 here. So I need to put a 2 in front of this compound to balance the amount of oxygens. As soon as I do that, though, it affects the potassium. So now I have 2 times 2 potassiums. I have 4 on this side. So now I would have had to cross this one out or erase it and write a 4. Again, I have 2 oxygens. 2 times 1 is 2 oxygens. 4 times 1 potassiums, and 2 times 2. So I have the same amount on each side. Let's take a look at this one. I'm going to start balancing, let's say, sulfur. I could balance the oxygens, but one of the hardest elements to balance in an equation is usually oxygen, so I try to stay away from them for the most part. I have 8 sulfurs on this side and 1 over here, so I'm automatically going to put an 8 here so my sulfurs match up. And now I will do my oxygens. I have 8 times 3 is 24 oxygens, so I need to have a 12 on this side. So I have 24 oxygens on this side. Here is a reaction, and again, the only thing that's out of balance right away that I see is the fact that I have 3 oxygens here and 2 on this side. You often will find that it isn't just by placing one number in front of a compound that balances out your element. Sometimes you have to think of a common number that they both share. This has 3 and that is 2, and so 3 and a 2 share 6 as a common value. So if I put a 3 in front of this compound, I will have 6 oxygens. I have to put it in front of the compound, and I will have 6 oxygens on this side. Again, though, this 2 affects potassium and chlorine. I now have 2 each of those on this side, and so I need to multiply this by 2. I'm only multiplying this by 2 because I'm trying to get the same quantity on this side. And if I go back and recount all my atoms, I'll have the same number of potassium, chlorine, and oxygen on each side. This is a polyatomic shortcut, and this is a tip on how to balance. One of the things that stands out to me is the fact that every compound has an oxygen in it. So if a compound more than one compound contains the same element, automatically that's going to make it a difficult element to balance. And so because it appears in multiple reactants and products, it's just going to be a bad thing to try to balance. But if I see them as a unit instead of individual sulfurs and oxygens and nitrogens and oxygens, it can make it easier. And this will only work if you have the same polyatomics on both sides, which I do. I have a nitrate over here and a nitrate over here, a sulfate here and a sulfate there. So let's just balance the polyatomics as units. I have 2 nitrates on this side. I have 3 nitrates on this side. So again, there isn't a magic number that will make those balanced other than they share a common number, which is 6. So I'm going to multiply this side by 2 to get 6 nitrates. To do that, I need to put the 2 in front. And I'm going to multiply this side by 3 to get my 6 nitrates. So on both sides now I have 6 nitrates. Let's take a look at our sulfates. I have 3 units of sulfates on this side, and I have 1 unit of sulfate on this side. They share the common number of 3, so if I put a 3 in front of this compound, I'll have 3 sulfates and 3 sulfates. Go back and make sure that your metals balance. I have 3 times 1 calciums, 3 times 1 calciums. I have 2 aluminums and 2 aluminums. So they balance by doing the polyatomic shortcut method. Last ones are called combustion reactions. They are the most difficult to balance. However, they're the easiest, again, to predict the products. It's a carbon-hydrogen compound burning an oxygen, and they always make the same products. This is what happens with your barbecue. These are just some tips on how to balance these. Again, because oxygen appears in multiple compounds, automatically makes it the worst. Also, oxygen and hydrogen are notoriously the hardest ones to balance in a compound. So the first thing I'm going to do is multiply the carbons, or balance the carbons. I have 3 carbons over here. I have 3 then now over here. I'm going to balance then the hydrogens next. I have 8 on this side, and to get 8, I'm going to have to put in front of my plus sign. I have to put a 4 in front of there, so now I have 8. Now I'm going to balance the oxygens now. I have 3 times 2. I have 6 oxygens over here, and I have 4 on this side. That gives me a total of 10 oxygens. Because I have 2 sources of oxygens, I need to add them up together. And so to get 10 on this side, I just need to put a 5 over here, and I have 10 oxygens.